Alright, our next topic related to solutions is electrolytes. So we know that when ionic compounds dissolve in water, they dissociate into ions. So if we have a solution of sodium chloride, we don't have little sodium chlorides floating around together. The chloride ions and the sodium ions are ripped apart from the rest of the solute. They're surrounded by water molecules. Of course, the positive end of the waters would interact with the negative chloride ions, and the negative end of the waters would react with the positive sodium ions. But we have individual ions floating around, and so we say that the solute dissociates or ionizes. Covalent compounds, on the other hand, when they dissolve in water, they don't dissociate. So many covalent compounds are soluble in water. Ethanol, that we've talked about previously in this chapter. Sugar is another example. So covalent compounds that dissolve in water, because of the like dissolves like principle, typically have to be polar and often can undergo hydrogen bonding. And so they still get surrounded by the solute particles, but they aren't dissociated. The positive hydrogen in ethanol react with the negative oxygen in water, but the covalent compounds don't get dissociated, so they remain together. Now, of course, acids are a special but important group of covalent compounds characterized by the fact that they interact so strongly with water that they actually do dissociate. Now, we have both strong and weak acids. What makes a strong acid strong is that they completely dissociate into their ions in aqueous solution. So if we take HCl, hydrochloric acid, is one of our strong acids. When I dissolve that in water, so HCl would be a gas normally at room temperature. When we dissolve that in water, so we're dissolving water, let's put water over the arrow, it will completely break up into the hydrogen ions and the chloride ions, and we have very little to none of the HCl molecule remaining. Weak acids only partially dissociate in water, and so a very common weak acid that we've used in lab and used in a lot of examples is acetic acid. And so when we try to dissolve that in water, some of it will break up into the respective ions, but for weak acids, usually less than 1% actually dissociates, and 99% or more of the molecules remain together. And so that's why for weak acids, I would use a double-sided arrow representing equilibrium rather than the one-sided arrow representing that it goes to completion. Don't stress too much about using the one-sided or the double arrows. We'll talk a lot more about equilibrium in a couple chapters. And so for our purposes, the strong acids that you need to know are listed down here. There are other strong acids, but these are the common inorganic acids that you should know. And any other acid that you're given as an example in this course, unless I tell you otherwise, you can assume if it's not in our list of strong acids, then it must be a weak acid. Okay, so finally to the idea of electrolytes. So it turns out that pure water does not conduct electricity. In order for an electrical current to flow, we must have a movement of charged particles. And in water, there are no charged particles. However, if things are dissolved in the water that dissociate into ions, now we have charged particles. And so the movement of those charged particles in the solution can conduct a current. So pure water does not conduct electricity. But if there's electrolytes, so ionic compounds or acids, dissolved in the water, the solution can conduct a current. And so, reasons why they say don't take a bath with your toaster. In principle, if you had pure water it wouldn't be an issue because your toaster is not going to conduct electricity. But the water coming out of your tap has all kinds of stuff dissolved in it, plus any stuff on your body that dissolves in your bath water is going to create electrolytes. That's going to allow that water to conduct electricity. Don't take baths with your toaster, using pure water or not, please. Alright, and so then when we think about electrolytes, we can have strong electrolytes. These are compounds that almost completely dissociate or ionize upon dissolution. And so a solution of strong electrolytes will conduct electricity very well. If we had a solution of that acetic acid, the molecules only partially dissociate, so that would be considered a weak electrolyte. It'll conduct electricity, but not very well. If we took something like table sugar, sucrose, and dissolved that in water, that's a covalent compound. That's not an acid. It does not conduct electricity. That would be considered a non-electrolyte.